What attacks steel casing? In this article we will discuss some of the major enemies of steel pipe, which are laid underground, and the ways to minimize it in the best possible way. This can be in the form of bore casing, rising main, steel column and shaft. There are three main culprits: stray currents, total dissolved salts, which is often known as TDS, and groundwater quality. One of the major threats to underwater steel pipes are DC currents as well as AC currents, which can also be termed as stray currents. This is caused by immersion of steel pipes in a conductive medium. It basically happens when two different material types of metals are in the ground, especially if they are at opposite ends of the galvanic scale. Steel column and casing in the ground has seen a noticeable difference in lifetime spans over the last 8 years. In some areas we have seen the lifetime gone from 15 years plus to 2 years or less. Most of the stray currents, which can be both AC and DC, come from electrical wiring that is laid underground or earthed in the ground. Most of the AC currents come from the leakage from local power supplies. This can be rectified by the authority. DC currents, the local Catholic protection of electric fence, etc. Earthing should be installed correctly to minimize stray current. This can be checked by a standard voltage and amp meter. If you have an electric fence or telephone lines near your steel pipelines, then you are prone to lose almost 40 pounds or 18 kilos of steel annually by only having 2 amps of DC current. This is why periodic checkup by the local power authorities or electrician must be done. Even sacrificial anode attachments to the steel pipes will make a difference. Now, the second biggest enemy of the steel pipes is the TDS, which is total dissolved salts. If the concentration is above 700 parts per million, then the pipelines are prone to corrosion. TDS meters are easily available, or you can have a water sample checked before laying pipelines or installation of casing and column, and periodically inspection is suggested. The higher the TDS, the higher will be the potential of corrosion taking place. The third problem with the steel pipes is the groundwater, which is quite prone to the high bacterial concentration again. The corrosive enzymes released by some of the bacteria present underground increases the steel pipe's corrosion by almost 250%. Most common types of bacteria are sulfate reducing as well as the iron reducing bacteria. Both of them at humid conditions help in a faster corrosion of the steel pipes. Other prime causes are iron biofouling. The most common way is to get the water checked and then apply a general alkaline solution to the outer perimeter of the pipes, and even look at other solutions to this problem. The coliform count of the underground water is also one of the major problems that the urban cities are facing. The E. coli and coliform count of the groundwater must be checked periodically, and therefore should be treated by alkaline solution and other disinfectants. You need to be aware of the potential dangers and take periodic checks of the TDS, pH, stray current, the bacterial concentration, and the groundwater analysis, and act according to the results urgently. How can I minimize this problem? Check earth stakes are working and in good order. Check for stray voltages, AC and DC. Neutralize water conditions. Use non-corrosive metals. Similar metals on the galvanic scale. Thank you for taking the time to look at the information we have created for you. We hope this will be of assistance to solving your piping, drainage and drilling challenges. If you have any more questions, please feel free to contact myself or one of my team, Victor Little. For more articles, case studies, how-to and information, go to www.deps.com.au. Then click onto handy links or contact us on 1300 133 000, or you can email us. DEPS products and capabilities. Solving your piping, drilling and drainage challenges with trust and integrity.